what it's supposed to look like. Some of the jobs we have coming up and some of the jobs we're currently working on, they're getting bigger, they're getting more in depth with waterproofing and outside consultants. I mean, even insurance from some standpoints. We have to submit some items for the Cerner job we're doing just to get approval that we can lift something a certain way. So when we get to these jobs, we've got to make sure we understand what's going there and how it works. We don't need to be pulling stuff out. We pulled some out already that were just ridiculous. We have a job that we did a few years ago that we accepted that they pulled out some wood blocking, and our flashing's doing this all the way up and down. And over the last 3 years, you have puddle spots. You know, just you can see where the shims held it, and part of the issue with it is, you know, we accepted it. We probably could have shimmed it better. You know, you can always look back at what we could have done different. We got to start doing that now and do better with it. As project managers on our side, some of the things we need to do is if we get a much larger, you know, sill flashing, we need to look at using thicker metal. You know, if you guys see that when you're putting this stuff in, mention something to us about that, help us out, because sometimes when we see it on paper, we're just so used to doing 040. You know, we get above a certain point, we need to probably be using 063. It does cost a little more, but not enough to have to worry about going back and replacing it later. You know, and that's a judgment call we can make. You know, same with corners, things like that. You know, those are the couple examples that I have, but it just from number one, we can never put flashing in flat or at a negative slope. Flat is just as bad once you get past 4 or 5 inches, because over time it's going to find a low spot in that flashing. I mean, it's just going to. There is going to be a low spot in an 040 metal that's running there, or even the substrate that you're running with. So we have a lot of jobs where they're helping us. They know lead times. We have guaranteed openings. You get to the opening and the brick is higher than the studs or whatever it may be, or if it's a stone sill and it doesn't fit, we need to make them fix it. Whether that's grinding it, whether that's pulling the brick, you know, we have that ability on some of these jobs. And in most cases they'll do it. Some cases they won't. In some cases we may have to shrink the window if it hasn't been, you know, if it wasn't a guaranteed opening we just measured. We can't keep putting it in and having these negative slopes and having issues with it. Most of the time, if it's a negative slope, it's really not causing water issues. You may not get water in the building. It's the perception. It's the fact that they can just flat out tell us we got to pull it out and redo it. So some of the things that we've gotten the ability to do, we've stopped the architects and everyone from having us turn, you know, all the end dams up on sill flashing and back in behind because of the thermal transfer. But what we're seeing on some of them, one of my first examples is sill flashing, and we're wrapping the openings with just flat metal. Okay, I've seen a few. We don't do it very often, so I just wanted to show what we expect and how it should be done. So if you're doing your sill flashing, you have an end dam on it. They're still going to want the end dam on the sides. And I've cut this, if you see, a little bit short here. And the reason for that is if your jam metal is just flat, just cut this a ½ inch short, the same as your hem, so it doesn't roll on you, and they can slide in together. And you still have the overlap. You have to have the overlap on this. So you always turn your sill metal up. Your jam metal goes in next. If you're wrapping the jam, your jam metal then turns a tab on the head. Then your head metal goes on last. We've had some where we've done this, and we've just done a straight butt joint, you know, on this side, just like this, and caulked it. I mean, we're just relying on caulking. It doesn't seem like much, but when this tab is up and you put caulking on this tab, it is that much more protection. So this is what we expect. The Church of Resurrection, I think, that had a slope on it. So we had a piece of flashing, we did something similar, and the flashing came out and then stepped down, so it had a big slope. When you're doing this metal, I've seen somewhere when this is coming out, and if this is on a slope, we've actually set our metal like that and had to redo it. I mean, it seems like you shouldn't have to talk about this, but I've seen it done. And we have to cut that to the angle that's there. You know, I mean, it just has to be. you have to turn it up as well. So you have to follow it all the way around. I mean, it seems pretty obvious, and I see some people chuckling, but we take for granted that it gets done all the time. It's happened way too many times. The corners, I've seen most of the time. Sometimes people are cutting your corner and just bending them together. And personally, I think it looks like shit. I don't think we should be doing it then. You get an automatic splice joint when you do that. The way that we should be doing it is mitering them at a 45, and you can use a square piece. The face is generally not a huge issue on your splice. You can caulk the splice. Your splice is about water hitting this and not getting down under. If it gets over the edge and you don't have a splice in the front, it's not as big a deal. So if you cut these on a 45 and you just cut another square piece, you can get you a splice in your corner and have your caulking in it, and you get a much cleaner seam. Okay? We shouldn't be cutting a straight piece and trying to bend them together. You'll never get a good look. How are most of you guys doing the corners? Like this? Yeah, you have to. Okay. It's funny everyone's doing that, but we have jobs that are, I know everyone's not here, but we have jobs that they aren't doing it on. So wrapping corners with brake metal, which is happening more often, same thing. If you have L angle that you're wrapping, one of the first things we need to know is when we wrap our L metal into the opening, we have to tie it into the air barrier afterwards. Because if there's an air barrier on the building and you put this on and there's nothing that can stop water from getting from this backside and in, we've just ruined the water protection from the building. So sometimes they're okay with just putting caulking on this face, putting it in, and going with it. Other times we have to put this in and this gets stripped into the air barrier or caulked into the air barrier. So if we're wrapping an opening you're always starting with the sill first, okay? Sill always has to go in first. You turn the leg up. And if you're wrapping it with an L angle, you have to cut it with your tabs like this. You have to have this lap. And the reason for that is you don't want a butt joint without it. When you have the lap, you have the shingle effect on this. So that any water that runs down that, you still have a shingle effect. If you don't have this tab here, you're putting this over it and you just have a corner right here at the bottom that's a weak spot. As soon as that caulk fails, it's going to come right in, you're inside the systems. You have to do these laps. So you're putting the sill in first, you're putting your jams in. Your jam has to have a tab on the bottom, and you turn the top side into the underside of the head of your opening. So you have this. It goes into the opening, and your head then comes into it underneath, and you have the same shingle effect. By having the head go in last, you get, for everyone on the other side, you get a shingle effect from water running this way, and it's running down. You do not want to end up with a shingle effect like that, because you have a line in the front. Once again, you've now caused another weak spot in this corner. So it has to shingle on the outside. You always want to shim outside of it. You don't want a vertical line unless it's at the bottom. So when you're doing this, something that we actually just recently found out, and one of the sheet metal guys was kind of explained it out of Garmin. We had an issue, and I was the one that said to do it because I thought it was a good idea. You put your caulking right here in the corner of this and put it in on the corner, because it's right there in the corner. You know you're going to squeeze it in. The problem we had with that is if anything's off a little bit or if this rocks, it's turning it or kicking them out, because that caulking's sitting right in this corner where you got to try to get it tight. And what happened out there actually a couple times is we had it in there, and either just after it got screwed in, it twisted a little bit, and it basically made the opening, dive in the front. And at that point, once that silicone or urethane sets up, you're done. You got to peel the whole thing off because there's no moving it back in. So we actually need to pick, if we're going to caulk it, it needs to be caulked on the face and put it on. And preferably the face that you're screwing it onto. We also need to find out if it's possible, as you're doing it, to have fasteners on both sides and pocket screw heads. It's going to be a job-by-job situation, but we have to know which one we do. We have to do a good job of letting you know what we need to be doing on that. You know, it all starts with us. There are times that, like I said, we take for granted that you may have been doing this 10 years, 2 years, however long, but we don't do a ton of metal in openings like this. We are getting into more. There's some jobs that, we have several jobs right now that just have a ton of brake metal on it, and it's getting a lot of, we're having problems with it, basically is what it comes down to. And it's little things that just like this that we didn't talk about ahead of time. A couple little steps would have taken care of it. So that's where we came, why I wanted to do this. One of the ones that I didn't do a sample of is your corners. If you cut a inside corner, I'm just going to bend these under just as an example. If you have a corner brake metal that we're putting on an outside corner or in a curtain wall, top and bottom, you have to bend about a 1-inch tab minimum so you can get back rod in there, and it needs to be in the same plane as your primary caulk joint. If we just set an inside corner to the ground right here, and we try to run our caulk joint all the way through, we're caulking to 040 metal. It's never going to hold. It's a weak spot right there that come right into the corner. You know, some of the waterproofing things we're doing inside those corners will help not get it into the building, but it still is going to be a failure spot on our caulking. Those inside corners need to be cut, turn back those tabs so the back rod can go back there and you have a clean caulk joint that runs at the same location as the pressure plate all the way back and around. So you have a continuous line and you're not just caulking to the edge of this. So I am open for suggestions and thoughts on any of this that you don't agree with. I think this is how they all should be done. You know, if there's other items out there that we're doing a lot of that you guys have want to share with, I want you guys to kind of bring up some of the things you're seeing and doing, issues you have when you're at the openings, things like that. So what do you guys got? Anything?
Well, I think everybody needs to understand on long runs they got to have
Oh shit, I forgot about that
splices
one.
or
Yeah.
something.
I've got that too. Yeah, I had it somewhere. Go ahead though.
Well, I mean, either depending on how long the run is and how heavy a metal you're using, you know, you got to have a splice underneath your sill flashing or head or whatever you're doing, and have a 1/4-inch gap between them. Because otherwise, especially on the south side of the building, and we've seen it, and I've torn a lot of it off, that metal expands a lot. And
Yep.
I've gone out to a job where a 10-foot piece of metal was bowed almost a foot up in the air.
Yep. I use example of that when we talk about how much aluminum expands in the heat and cold. I was wondering, man, do we really have to have that much extra room at the head, the caulk joint, this or that? We were at ATSU on the roof, and there was an extrusion of extruded sill metal that was in place, and we took it off because there was a water issue. We were trying to find it. We took it off, set it on the roof, and it took 4 of us to get that thing back in place because it got so hot and grew enough that we couldn't get it in place. We had to lift up and bow it into place. It was so tight. It was the first time that I was able to physically see that how much this stuff does move. So basically what we're saying, and I don't have a splice place for this, but if you're putting a sill flashing in and you do a splice that is over 20 foot, you need to have a 1/4-inch joint in it. So when you do your metal, you need the same finish color metal underneath it, and it needs to have a gap between it. You're still caulking both sides. You're still caulking all of it, and it may not seem like it, but it'll move, and it'll keep you from having that stuff falling up.
I would say if it's 140-inch opening, if any time you're using 2 pieces of
Yeah, anytime it's 2 pieces of flat,
1/4-inch
you should, because you have over 10 foot.
Right.
It's similar to Conair's subsill expansion.
Yep.
You know, after 12 foot, you got to have an expansion in the subsill. Same concept, but just don't line them up. You know, when you're doing this, it's the same thing. It's kind of like your splices in your subsill. Don't put it next to a weep hole. You know, you shouldn't have issues with it, but why add extra problems and extra water to a splice location right where all the water's going to leak out of it? So those are things to look at. What else do you guys have? Any other?
You know, you talk about you accept the opening. You might want to talk a little bit about, if you do the flashing, but if somebody else has done the flashing or the air barrier, and it's not right, you might talk about it.
Right.
Examples.
And that's one of the things that all the project managers need to do a good job as well. I keep saying, we have to understand every system we're going around. Brick's pretty simple, but lintels, we got to watch penetrating lintels. I mean, as you go through the different substrates, it should be designed where the waterproofing and through-wall flashing of the lintel is higher or steps out away where we have to fasten, but it happens all the time. Ian's got a job right now that we're doing a window replacement, and there's not supposed to be a lintel there. Well, there is now, and there's no visible through-wall flashing. The only place we have to fasten is in that lintel. If we go up through that lintel, we're taking a chance of water coming into the head of our system and have a water leak, and it'll be ours because there was not a hole in it before. So we're coming in with some strap anchors back, and they'll have to figure a way to hide them. So brick's pretty easy. You got to watch your lintels. You got to make sure you understand what the drawings show for that. We try not to screw in the lintels anyway, just because it's a pain, but sometimes it happens. When you're dealing with EFIS or any type of material like that, sometimes they'll have a head flashing that's at the top. We need to make sure that that's all installed right and there's not joints and bad spots right in the corners. Metal panels are probably the most difficult. We have to understand how their system stops water. Some metal panel systems are not waterproof systems, and they are just purely that water will get into them, and at the openings you're just relying on whatever the end of their systems are. Just like our subsill has end dams, metal panel systems that take on water have an end dam system at the edge of a window, edge of any opening. We have to understand and know how that's working. If we don't, we have no clue. Exactly, we have no clue if we're accepting something that's right or not. A lot of this type of metal is how most of those metal panel companies close off their openings. Jeff Shawhan showed me a lot of these things and how they do it. Just as I thought I knew what we needed to do, just to get some reassurance that we are correct. But this type of lapping is what they're usually doing with their systems. Again, we have to make sure you understand it. You're not going to get a 3D drawing of every job you're on. We're going to do some of the basic ones for us, but we have to make sure, and you need to ask us as well. If you go to that opening and you don't know what you're looking at or how something is weeping, we need to ask. You need to make sure you make that phone call to us and see if we can make sure it's right. So, what else you guys got? Because I'm going to go on to some other outside of metal flashings that we're having issues with too. But I mean, some of the metal, like I said, it seems like common sense, but we're having issues with it. So we need to make sure if you don't understand it, ask questions. If you're not 100% clear.
The only thing that I've seen lately is a lot of the brick metal that's coming out is, perfect example is some of the skins I was using today, 2 inches on one side and 1 3/4 inches on the other. And I've gotten a lot of flashing out in the mornings anyways, where one side is just a little bit bigger, usually within an eighth or quarter of an inch, where when you come together, they're completely different sizes.
Are you letting Quentin know that?
Yeah, letting the PM know.
Okay. Yeah, I mean, we just need to